This is module 30, surface area and volume of spheres. In previous modules, we had an entire group of modules that were based off of circles. The three-dimensional figure circle in parts, if you go at certain levels, is called a sphere. So basically, it's a set of all points. If you have a center here, which is the center, it's equidistant. So if you were to draw lines from this point, from the center, and continually do that throughout, all over the place, infinitely many times, each one of the points that's created would eventually create a sphere. So the sphere is a set of all points in a space equidistant from the given point. That given point is called the center, is the given point from which all points on the sphere are equidistant. So, the other part that's important is a radius, which is what I was just drawing. So one of the points, one of the distances from the center point to an outer edge is called your radius, and it's a segment from the center to a point on the sphere. And the last thing, if you continue a radius all the way through, you get a diameter, just like a circle. So a diameter of a sphere is a chord that contains the center of the sphere. So there's your example of a diameter. So again, just like in circles, diameter, if you take half the diameter, that's equal to the radius. And we're going to figure out, again, surface area and volume formulas as well. So, surface area of a sphere we'll start off with. And these are a lot easier, I think, than prisms because you don't have certain things you have to look for. It's literally just plug and chug. So a surface area of a sphere is 4 pi r squared. And depending on what I ask you to use, you can use either the pi button or the 3.14 as pi, but pay attention to what I'm asking you to use, and you should be good to go. So r is the radius of the sphere, pi is pi, and you just plug it into the formula. So in this case, it says find the surface area of the sphere. So again, you have to just kind of know your formula, which is 4 pi r squared. So 4 pi r squared, you plug in what you know, which is your radius. When you do that, you get 256 pi. So if you were to multiply 256 pi, so 256 times the 3.14, you get roughly around 803.84 if you use the pi button. So this is rounded when you just use the pi button. Without the pi button, it would just be, or if you used 3.14, it would be 804.24. It's going to be important when you plug in things into certain quizzes. So, again, do not forget that you have inches, and in this case, since it's surface area, it'd be inches squared. So, surface area is square units. And in the formula itself, you have the squared to indicate surface area. Okay, so we have the surface area of the sphere is 20.25 pi square centimeters. What is the diameter of the sphere? So what you have to do algebraically is set up. We know 4 pi times the radius squared is equal to 20.25 pi. Now, it's up to you if you want to use the pi button or the 3.14. It really doesn't matter because what happens if you use an algebraic division, the pi's will actually cancel out. So whether you use the 3.14 or the pi button, you'll still get the same thing. So in this case, I'm going to divide by 4, get r squared is equal to 20.25 divided by 4, which gives you 5.0625. Get rid of the squared, you take the square root. Technically you have plus or minus, but again, since we have just geometry and its dimensions, you only take the plus. So it'd be 5.0625 square root, which would be 2.25 is your radius. So once we solve that, that means that it would be 2.25 centimeters would be the answer. Okay, so one of the cool things about spheres is they're actually used a lot in automotive engineering. something that we're going to be talking about and referring to throughout, because it holds true in the second figure that I'm talking about. But you have something called a great circle. And a great circle is the intersection of a sphere and a plane that contains the center of the sphere. And the reason that's important is because you're taking this two-dimensional figure and you have a circle that is created. It's the biggest circle that occurs within the sphere. That's why it's called the great circle. So the second term here is a hemisphere. So a hemisphere is one of the congruent halves of a sphere. And if anybody knows Dodge, the car company, what they use in their cars is something called a Hemi. So right now I think it's at a 6.1 liter Hemi V8. And all that means is that the cylinder is actually represents half of a sphere. So it's one of the congruent halves of a sphere we call a hemi, or a hemisphere. So you can call it a hemi for short. Okay, another thing that's important is surface area. I could ask you the surface area of a hemisphere. What a lot of people think is that all you do is cut the sphere surface area in half. So we know surface area for a sphere is 4 pi r squared. So if you divide it in half, you get 2 pi r squared. Well, here's the problem with that. If you cut the hemisphere in half, you actually have this bottom circle that you haven't accounted for in the formula. So this part here accommodates for the actual sphere part, or spherical part, hemispherical part, but the bottom part here, you have another pi r squared. You have another circle that is covering the surface area. So if you were to add the two together, the surface area of a hemisphere, which is going to be important, you're going to need to know, is 3 pi r squared. Because you add the 2 pi r squared plus the bottom circle, which is pi r squared, and you get a total of 3 pi r squared. So you will need to know that. Okay, so we have this particular one reminds me of American Gladiators in the 90s, a sport called sphering, where a person rolls down a hill inside an inflatable ball surrounded by another ball. The diameter of the outer ball is 12 feet. Find the surface area of the outer ball. So go ahead and pause the video and try and see if you can figure out what the diameter is. Okay, so here's your solution. So we know that the diameter of the outer sphere is 12 feet. So what you do is you divide that by 2 to get the radius. Then you just plug it into your formula, 4 pi r squared. Your r is your 6, so you plug it in, you get 144 pi. And again, depending on if you use the pi button or the 3.14, so if you use the 3.14 times the 144, you get 452.16. If you use the pi button, you get 452.39. So 452.16 square feet, or feet squared. Either one is acceptable. Most of the times in the quizzes I'll ask you to use 3.14 so we can be consistent. Okay, so we have the volume of a sphere. We were talking about surface area, now we're talking about volume. And again, straightforward plug and chug formula. So volume of a sphere, all you do is do 4/3 pi r. In this case, it's cubed because we're talking about volume, where r is the radius of the sphere. So this is, again, one of those formulas you need to know how to manipulate and use. Okay, so we have real-world application. You have find the volume of a sphere. The soccer ball has a diameter of 9 inches. Find its volume. So in this case, you have a diameter, so that means you have to divide it in 2 to get the radius. So we know the radius is 4.5 inches. Now we apply it into the formula. So 4/3 pi r cubed, and depending on what you actually use, you plug it in. I'm going to use just the 3.14, so 3.14 for pi. So you do 4/3 times 3.14 times the 4.5 to the 3rd power. And be careful how you actually plug this into your calculator. You should get roughly around 381.51, and that would be inches. In this case, it's cubed. But if you were to use the pi button, you would get roughly around 381.70. So there's subtle differences. If you were to build something that would involve spheres and circles, I would advise you to use the pi button, just because it'll help you out with your measurements. So, but in our case, just for calculation reasons, I'm going to mainly see if you can actually use the formula. So you could say 381.70 cubic inches or 381.51 if you use the 3.14. Okay, and now we have composite solids, which we did in the previous module as well. So find the volume of the composite solid. So what I want you to kind of think of this as a cylinder, like a Coke can, and what you've done is you've taken out a hemisphere from the Coke can. So you basically have to think of the volume as a cylinder, and you subtract out a hemisphere. So let's see what you got. Go ahead and pause the video and see what you can do. Okay, so solution, you have again, volume of the solid equals the volume of the cylinder minus the volume of the hemisphere. So plug in what you know. We know volume of a cylinder is pi r squared h. So that's from a previous module. In this case, we know the radius is 2, and we know our height, our thickness, is 2 as well. That's from this dimension given here. Minus, and it's half of, the 4/3 pi r cubed, because it's volume. Okay? And the reason, again, multiplying by half because it's half of a sphere. And remember, in hemisphere surface area, that's when you have to compensate and you have to add the circle at the bottom. But in this case, it's hemisphere's volume, so that means you just have the full sphere formula. So plug in what you know. So I have 2 is my radius, my height is 2 as well. All I did here is I simplified, said that 2 goes into 4 twice, and gave me 2/3, and my radius again is 2. In this case, I used the pi button, so I gave about 8.38 cubic inches. So depending on if you use the pi button or 3.14, you should get roughly around 8.38 cubic inches.